welcome. Myself, Professor Vikash Katariya, and you're watching lecture based on operating system. This is lecture number 7, and the topic which is going to cover in this lectures are process state diagram and types of CPU scheduler. In the last lecture, we had discussed about the process and their context. We also had discussed about the PCB, process control block. What is the major component of PCB? We already discussed. So let's start today's discussion. Process state diagrams. The mostly frequent asked question from the GTU is, what is the 5-state process model? So as you can see the diagram, there is 5 states process model in which process belongs to number of states. Maybe process in new state, then after it will go to the ready state, then ready to running state, then after termination. At the time of executing to the process, there may be chance that process gets interrupted by some other process or a CPU, and process change the context from running state to waiting state. Afterward, the process which is stored into the waiting for the processor, it will again reschedule by some programs, then it will go again to the running state. So how process complete their own life cycle? Okay, so we will discuss one by one. The first state is new state. In which the new process has been created. This state indicates the process has been created. So let me write here. This state indicates that new process are being creating by the user. So anytime if user creates a new process, that means the process takes first state in the new state. Second state, ready state. Ready, this state indicates process is waiting to be assigned to a processor for execution. So if any process which comes from new state to ready state, that means the process is ready to go for execution, right? CPU will be allotted into the running state. Okay, so ready to go position, the process is in ready to go position, ready for the execution. So this state indicate process is ready to be assigned to a processor for execution. The state 3, running state. Now this state indicates that the instructions are being executed. Process is currently executing by the CPU, and CPU physically allocate to the process. This is called running state. So this state indicate instructions or process are being executed by CPU. Step 4, terminated. So after the end of the execution, the process gets terminated, means the process has been completed their execution. Okay, so this state indicate a process has been finished execution from the process control block. And the last state is waiting. So at the time of executing the process, there may be chance process required some input output event, process required some input output operations. The higher priority process may comes into the running state at the same time, so CPU gets interrupted to that process which is being running by the CPU. So somehow we need to swap out that process from running state to waiting state, and the process has to wait into the waiting queue for reschedule, because the higher priority process came at the time of execution, right? And in that case, the process must store into the waiting queue. So let me write here waiting. This state indicate a process that cannot execute until some input output event occurs, such as the completion of an input output operation, assigning the higher priority to process non-maskable interrupt. So in that case, process switched from running state to waiting state, right? So these are 5 states. New state, in which the new process is being created. Ready state, after creating the new state, the process is ready to execute. It will store in a queue which is known as ready queue. After the end of execution, the process gets terminated. So processor release all the context of the process and all the resources engaged by the process in the running state at the end of execution, right? And if in case of any interrupt, in case of any non-maskable interrupt or input output operations or a higher priority of process, in that case, in any situation, if these kind of situation occur into the running state where the processor is allocated to the running process and executing to the process may gets interrupted by the other process and process swap out from running state to waiting state. So there is a queue which maintain the process which is being waiting for the rescheduler for re-execution also. Ready is a state where again a new where a queue will be maintained for those processes who are ready to go or ready to execute. Running states also maintain a queue for scheduling uh, for scheduling the process for execution. Okay, so this is what about the 5 states model. New to ready, that is called admission of a new process. Ready to running, the scheduler dispatch. Here I am using the word dispatch, means the scheduler which works in between ready state to running state is known as dispatcher. Then after the end of execution, the process gets terminated if any input output requirements not occur or any input output event are not occur. In that case, the process gets terminated. Suppose the process could not terminate it with some cases, so process may be interrupted by other process, so CPU swap out that process from running state to again ready state, or processor again maybe swap out this process to the waiting state. Waiting states, then again a scheduler will work to reschedule the process from waiting state to ready state. Right, so there are three different kind of scheduler will work to the entire 5 states process model. So let me discuss the 3 scheduler works between 5 states process model. The first is long-term scheduler, short-term scheduler, and medium-term scheduler. So long-term scheduler works in between the new state to ready state because it takes a long time to create a new process. So long-term scheduler works in between new state to ready state. There is reason because the new process, it will take a long time to create a new process because there may be a long time taken by the user for input or output operations. Maybe there are lot of typing works for a program, so that is why the long-term scheduler works in between new state to ready state, in between new to ready state. So the long-term scheduler admitted the new process to the ready state. So there is a set of programs which schedule some programs from new to ready. That set of program is known as scheduler, and the scheduler which works between new to ready state is known as long-term scheduler. Works between new states to ready state. Quite simple. Okay, let's have a look. Short-term scheduler. As you can see the diagram, CPU never be ideal, right? We always try to assign number of jobs, number of process for the execution to the processor. So CPU never be ideal. In order to achieve the better utilization or better throughput from the CPU, we again design a set of programs which known as dispatcher, or you can say the short-term scheduler, which works between ready process to running process, ready state to running state, which select a process from amongst in a very fraction of millisecond, right? Because processor never be ideal at any cost, right? So the dispatcher, or you can say the short-term scheduler, both are hand-to-hand. The dispatcher or a short-term scheduler works in between the ready state to running state. So let me write here, the short-term scheduler works between ready state to running state. Okay, now the medium term scheduler, in case of input output requirement, in case of input output event completion, in case of higher priority interrupt, process may be swept out from running state to waiting state. In that case, the process must schedule again by the scheduler. So there, between the ready state to waiting state, there must be some scheduler, there must be some set of programs which schedule process again from waiting to ready state, so that that process which is being not completed at this moment, it has to get chance to execution by the CPU, right? So somehow we need to manage. In that case, the scheduler works in between the ready state to waiting state is known as long term medium term scheduler. So works between waiting state to ready state. Okay, and scheduler is nothing, just a set of programs which schedule the process. Okay, for scheduling the process we need a scheduler, and scheduling is the policy in which manner we are going to select a process from ready queue. So that manner describe the scheduling policies, and the program which select single process from amongst that program is known as scheduler. So we have long term scheduler, we have short term scheduler, and we have medium term scheduler. Right? So there are three different scheduler works between 5-state process model. These are long term scheduler, short term scheduler, and medium term scheduler. Okay, in the next lecture we will discuss upon the Unix file system, Unix structure of process, because the Unix process management will not take the 5 state, it will take number of states, right? So it is quite complex as compared to this structure. So let's have a look in the next lecture. Thank you.